All right, before we were looking at what resistance do we need to have here, what type of resistor do we need to have here to get a voltage of 2 volts, 2 even. And right now I got 2.07 with a resistance of 100. But what I found is that if you had 210, you would get a voltage of 200, or resistance of 220, you would still get a voltage of just about 200. Now, if you go a little higher than that, like 230, your voltage falls below 2, like 1.99. So again, between 210 and 220 would have been the voltage that you need to, or sorry, the resistance that you need to find to get the voltage of 2 for this light. Okay, nice and red too. You get a little extra power. Okay, now we're going to put the voltmeter over the next light. Now this light is blinking off and on, so we would assume that the voltage is also going up and down, or it's adjustable, because it is connected to a tilde voltage, so it means it's analog. So it should be going up and down, up and down, up and down. So let's move this over, and let's get a little positive power out of this blue light, and then let's get negative power for this blue light. And now we're going to start the simulation and take a look at the voltage. And hey, as we predicted, it's adjusting. It's adjustable. It's going up and down, up and down, up and down. Oh, wow. Well, to be honest, the light is fading, but believe it or not, the voltage is not going up and down like we think it is. And the voltmeter really can't tell what's going on. We need something a little more powerful called a oscilloscope. Now, right now we're on basic. The oscilloscope, let's stop simulation and delete this multimeter. We want to go for the oscilloscope. So go to components, change from basics to all, and the oscilloscope is about halfway down. Let's see, where is it? There it is. Let's pull it over. Nice little oscilloscope. And let's put it over the first one. Now, the oscilloscope, let's pull this down a little bit. It measures voltage as well, but it does it as a graph or a line. It doesn't actually give you the numbers. And let's go ahead and connect a black wire here to the light, because we know that this is constantly getting a voltage. And let's go here. Again, this one doesn't tell you the numbers per se. Okay. And then let's turn on the simulation. And what we get with the red light, remember the red light, according to code, is high, or it's turned on. And you see the line, the blue line stays right here. This level is called level 1, whereas this level right here is 0. And this level right here is 1/2. This is 1.5, and this is 2. So it stays at level 1. Well, level 1 in the digital world means on. So this guy is acting digital because he is connected to a digital channel. Now, if I were to turn this to low, start simulation, and now look at where the line is. The line is at the 0 mark. Remember, up here is the 1 right here, and down here is the 0. And 0 does mean off, so it's off. Okay, so it works very well. So let's switch it over to the blue light and see if it does go up and down again. Sorry, if it doesn't go up and down, because it should be adjustable now. Okay, so positive power, blue light, and let's go for black. Negative power. Start simulation, and whoa, a lot of rectangles. Let's click this and slow this down a little bit. Let's go for 1 millisecond. There we go. Okay, a little better. Okay, so what you're looking at right now is that it seems to be at 0 for a little while and then at 1 for a little while, but there's no waves that are in the middle. So this means that this is not operating by being between 0 and 1. This just means that you're going to stay 0 for a little while and then stay 1 for a little while in order to get that flash. So what we're seeing that this is actually digital and not analog, because it's either 0 or 1, but there's no adjusting in the middle. In fact, what happens is it's basically staying 0. This right here stays 0 for a little while, then when it stretches to the other side, right here, this means it's staying 0 for a long time. On top, this means 1 for a short time, but as you stretch it over here, 1 for a long time. So it's actually just turning on and off very fast or very slow. So that's what's giving you a fading. It's not actually adjusting the voltage per se. It's just turning off slow or turning off and on very fast. And that's what your fading is. So really everything for the Arduino board is actually all digital. The analog is just acting digital, but it's not really adjusting. There is a such thing as analog, but this is just a pretend analog, and you're getting analog type states. But you're just using digital so fast, it looks like it's adjusting, but it's not. Okay, let's move our oscilloscope to the next light, which is adjustable. So let's delete our wires here. And move the oscilloscope over a little bit. There we go. And we need red, which is positive. And then we need black. Oops, keep that red. And then I need black wire, my negative. And remember, this is adjustable. So I can change it on the spot. Start simulation. And being wound all the way to the right, it stays mostly on the 1. If it stays mostly on the 1, you're going to get a very bright color, which is a very bright green. Let's pull this over to the other side and see what the oscilloscope says. Oh, it's staying mostly down here at 0. So it means that it's not turning on very often. A little bit, it'll turn on here and there, but most of the time it stays off. So because it stays off most of the time, it doesn't look that bright. Let's turn it over here again. And let's look at the oscilloscope again. All right. And maybe I need more here. There we go. Okay. And you see, according to here, it seems to be staying off just as much as it's staying on. Both of these are kind of even. So you got a kind of a, not the brightest green, but half of the time it's flickering on, half the time it's flickering off, and that's what makes it looks like that much green. And if I adjust it more here, I should have much more at 1, which is not moving, which is frustrating. It worked the first time. It's not working this time. Okay. Oh, there it is. Okay. So it's spending more time at 1 than it is down here at 0. So it should look much brighter. There we go. Okay. And that's your oscilloscope being able to do a better measurement of what's going on and demonstrate that we're still digital, even though it says we're analog.